So next is valve mechanism for horizontally opposed engines. Here you can see two figures. The bottom figure, if you see, this is your crankshaft and this is your camshaft. There is a timing gear on both the shafts. This is your crankshaft timing gear and this is your camshaft timing gear and this is your crankshaft timing gear. So a drive gear on the crankshaft, this is your crankshaft, a drive gear on the crankshaft, which is called the crankshaft timing gear, meshes with the camshaft gear. This is your camshaft, it meshes with the camshaft gear. So the crankshaft timing gear meshes with the camshaft timing gear to start the valve action. Turning of the crankshaft also turns the camshaft. So as the crankshaft is turned, this shaft, since the two gears are meshed, this camshaft will also turn. Since the valve operates only once during each cycle, and the crankshaft makes 2 revolutions per cycle. We have studied earlier that a crankshaft makes 2 revolutions per cycle and a valve operates only once during each cycle. The camshaft will only turn at 1/2 the RPM of the crankshaft. So the camshaft is going to turn only 1/2 the RPM of the crankshaft. A cam lobe on the camshaft, this is your camshaft, this is your cam lobe. So a cam lobe on the camshaft raises the tappet and therefore the push rod to which it is attached. Here in this figure on the top you can see this is your camshaft, the cam lobe. The cam lobe on the camshaft will raise the tappet. This is your tappet. We also call it a valve lifter. This cam lobe pushes the valve lifter or the tappet and this in turn pushes the push rod. Here is your push rod. This pushes the push rod to which it is attached. The ramp on each side of the cam lobe. This is your ramp. The ramp on each side of the cam lobe is designed to reduce opening and closing shock through the valve operating mechanism. So the design of the cam lobe is such that it reduces opening and closing shock through the valve operating mechanism. The height and contour of the cam lobe, you can see here the height and the contour of the cam lobe determines the distance the valve opens and the time it remains open. So the design of the cam lobe is very important. The height and the contour of the cam, this decides the distance the valve will open and the duration, the time it remains open. Valve springs normally hold the valve closed. Here in the diagram, there is a schematic diagram here in the bottom. You can see this is your camshaft, cam lobe. Here is your hydraulic tappet or the valve lifter. This camshaft, when it turns, it pushes your hydraulic tappet, which in turn pushes the push rod. There is a rocker arm here. This push rod pushes the rocker arm, which this rocker arm is hinged at this point. When this side goes up, the other side goes down and the other side of the rocker arm pushes the valve. This is the valve here, you can see, and these are your valve springs. This is your valve here and this valve is held by the valve springs. So in the valve operating mechanism, you can see this is your camshaft, the cam lobes, the hydraulic tappet lifters, then you have the push rods, you have the rocker arm, then you have the valve. This is the stem of the valve, the tip of the valve, this valve is held by the valve springs. The valve springs, these valve springs normally hold the valve closed. The valve is depressed against the tension of the valve spring. So in order to open the valve is depressed against the tension of this valve spring. The push rod raises one end of the rocker arm. This push rod, here you can see the push rod, this will raise one end of the rocker arm. So when this push rod is pushed, it will raise one end of the rocker arm, this side will go up and lowers the other end. So this, when this side goes up, this side will come down, thus depressing the valve. This will depress the valve against the tension of the valve spring. So this will depress the valve against the tension of the valve spring. When the cam lobe has passed by the valve lifter, now when this cam lobe, this has passed by the valve lifter, the valve will close by the action of the valve springs. So when the valve, since this camshaft is continuously rotating, when this cam lobe has passed valve lifter, the valve will close by the action of the valve springs. So now we come to valve lifter. Here in the diagram you can see there is a valve lifter. This is your cam lobe, this is your valve lifter, this is your push rod, and the internal mechanism of the valve lifter is shown here. What is a valve lifter? We also call it a tappet. What is it actually? It is a mechanism for transmitting the force of the cam to the valve push rod. So for transmitting the force of the cam lobe to the valve push rod, this mechanism is used, this tappet or the valve lifter is used. It converts the rotational motion of the cam lobe, into the reciprocating motion. So this lifter, this valve lifter converts the rotational motion of the cam lobe to the reciprocating motion of the push rod, and it transmits this motion to the push rod, rocker arm and to the valve tip, opening the valve at the proper time. Now what are the parts in the hydraulic tappet? So these valve lifters, they are also hydraulic. These days the hydraulic valve lifters are used. They are also called zero lash valve lifters. They maintain the clearance, the valve clearance to zero. And what are the parts in a hydraulic tappet? First is the cam follower face. This is your cam follower face here. It is the base of the hydraulic valve lifter or tappet assembly. So this is the base of your lifter body. It is the outer cylinder of the assembly. So this is your lifter body. This is the outer cylinder of the assembly. The hydraulic unit assembly, it is inside the lifter body. This hydraulic unit assembly, it is inside the lifter body and consists of the following. Number one is cylinder. This is your cylinder here. Inside the lifter body, you can see this is your cylinder. Then there is a plunger here. This is your plunger. Plunger springs. These are your plunger springs here. The ball check valve. This is your ball check valve here. You can see this is your ball check valve, and the oil inlet tube. This is here. This is an oil inlet tube. So this is a small unit, a hydraulic valve lifter, where you can see the cylinder, the plunger springs, and the ball check valve and the oil inlet hole. Now how does this valve lifter work? With the engine valve closed. Now when the engine valve is closed, the face of the tappet body or the cam follower is on the base circle or back of the cam. So this is the back of your cam. The face of the tappet body is on the back of the cam or the base circle. Any clearance in the valve linkage. So any clearance in the valve linkage is eliminated by the action of light plunger spring. So any clearance in the valve linkage, this valve linkage is eliminated by the action of this spring, which will lift the hydraulic plunger. So if there is any clearance in the valve linkage, this spring will lift the hydraulic plunger so that its outer end contacts the push rod socket. This is your push rod socket. This spring will pull this plunger, and this outer side will touch the push rod socket, which exerts a light pressure against it. As the plunger moves outward, as this plunger moves outward, the ball check valve moves off its seat. This ball check valve will move off its seat. Now oil from the supply chamber. Now there is a oil from the supply chamber. This supply chamber is directly connected with the engine lubrication system, and this oil flows in and fills the pressure chamber. So this oil comes in and it fills the pressure chamber. As the camshaft rotates, Now, when the camshaft rotates, the tappet body and the hydraulic lifter cylinder outward, forcing the ball check valve onto its seat. So, when the camshaft rotates, the cam pushes the tappet body. As the camshaft rotates, the cam will push the tappet body and the hydraulic lifter cylinder outward. So, when the camshaft rotates, this pushes the body outward. It forces the ball check valve to move to its seat. Now, once the ball check valve has moved to its seat, the body of oil which is trapped in the pressure chamber acts as a cushion. Then during the period when the engine valve is off its seat, that means when the valve is open, there is a predetermined leakage which occurs between the plunger and the cylinder bore. So, there is a predetermined leakage which occurs between the plunger and the cylinder bore to compensate for any expansion or contraction in the valve train. So, there is a predetermined amount of leakage which is continuously happening to prevent or to compensate for any expansion or contraction in the valve train. As soon as the engine valve closes, oil from the supply chamber, so as soon as the valve closes, the oil from the supply chamber is again pushed to the pressure chamber, which prepares it for another cycle of operation. So, this is a small schematic diagram of the mechanism, how the tappet or the valve lifter is working. Now, you will see a small video of the tappet, how the tappet looks like, what are the different parts inside. We will actually show you, we will dismantle an actual tappet and show you the different parts of a hydraulic tappet. Also, on one of our engine, we will show you how the valve mechanism is working, what are the various parts on an actual engine. The video is followed by this lecture, so you can see it in that video. Pushrod, it is a steel or aluminum alloy rod or tube between the valve lifter and the rocker arm of the valve operating mechanism. We have just seen in the schematic diagram that the pushrod, it is a steel or aluminum alloy rod or tube between the valve lifter and the rocker arm of the valve operating mechanism. It transmits the lifting force from the valve tappet to the rocker arm. A hardened steel ball, here you can see here a hardened steel ball is pressed over or into each end of the tube. It is tubular in form because of its lightness, strength, and allows the engine lubricating oil under pressure to pass through the hollow rod and the drilled ball ends to lubricate the ball ends, rocker arm bearing and valve stem guide. So, this push rod, this is tubular in form because of its lightness, strength, and it allows the engine lubricating oil under pressure to pass through the hollow tube. The push rod is enclosed in a tubular housing. Next is rocker arm. We have also seen the rocker arm in the diagrams. So, here also you can see the rocker arm. It is a pivoted arm. See, this is your pivot point, supported by a plain roller or ball bearings. You have the bearings here or a combination of this. This end, this is the push rod end. Here there is a socket which accommodates the push rod end, and this is the tip, this is smooth face to depress the valve. This rocker arm transmits the lifting force from the cams to the valves, resulting in opening and closing of the valves. One end of the arm presses on the stem, this presses on the stem of the valve, and the other end receives motion from the push rod. This receives motion from the push rod. The purpose of the accessory case is generally to house and drive the engine accessories. So, on a reciprocating engine you have various accessories. Here in the diagram also you can see some of the accessories shown. This is your accessory section. You have generator, magneto, tachometer, starter. So, this is the housing which accommodates all these accessories, and it is called the accessory section. It is constructed from aluminum or magnesium and is secured to the rear of the crankcase. So, this accessory section is constructed from aluminum or magnesium and is fixed to the rear of the crankcase. It houses and supports the gears for driving the accessories. So, all these accessories, they are to be driven by gears, and the gears are inside the accessory housing. So, this accessory housing houses and supports the gear for driving these accessories operated by engine power. It further provides mounting pads for the accessory units. So, here you have the mounting pads for mounting these accessories. The accessory drive gears are lubricated by engine oil. So, all the accessory drive gears, they are lubricated by engine oil and are housed in a cavity between the crankcase and the accessory case. So, the drive gears are lubricated by engine oil and they are housed in a cavity between the crankcase and the accessory case. There is a gasket which is generally placed between the accessory case and the engine crankcase. So, between the engine crankcase and the accessory case there is a gasket, and a gasket is also there between all engine driven accessories and the accessory case. So, a gasket is generally provided between the accessory case and the engine crankcase and between the engine driven accessories and the accessory case. Next, we come to propeller reduction gear. So, what is propeller reduction gear? Why is it required? Generally, the power output of an engine is directly proportional to its RPM. So, we all know that the greater the RPM, the revolutions per minute of a propeller, the more is the power output of the engine. From power to weight point of view, it is advantageous to operate an engine at as high an RPM as possible, subject to factors such as vibration, temperature and engine wear do not become excessive. So, from power to weight point of view, the more the RPM, the more power we get. But again, it is subject to some factors like vibration, temperature and engine wear. The propeller efficiency reduces when its tip speed approaches or exceeds the speed of sound. So, we all know that if the propeller tip speed approaches the sound speed or it exceeds the sound speed, the propeller efficiency is going to reduce. So, now here comes the requirement of a propeller reduction gear. The idea is that the engine should have the maximum RPM, whereas with the help of reduction gear we can reduce the RPM of the propeller. So, now we get more RPM from engine and with the help of reduction gear, propeller reduction gear, we are able to get more efficiency from the propeller. The purpose of the propeller reduction gear is to allow the propeller to rotate at the most efficient speed to absorb the power of the engine, while the engine turns at a much higher RPM in order to develop full power. So, in order to develop full power, the engine is being operated at a very high RPM and the propeller reduction gear takes care of the propeller efficiency. It reduces the RPM which is transferred to the propeller. The propeller always rotates slower than the engine when the reduction gears are used. So, with the help of reduction gears, the propeller RPM is reduced. Reduction gears are designed as simple spur gears, planetary gears, bevel planetary gears and combination of spur and planetary gears. So, there are various types of reduction gears. They may be spur gears, bevel gears, bevel planetary gears or a combination of spur and planetary gears. The propeller direction of rotation will be opposite that of the engine crankshaft, since the driven gear turns in a direction opposite to that of the drive gear. We all know that the direction of rotation of the driven gear is opposite to that of the drive gear. So, the propeller direction of rotation is opposite to the direction of rotation of the engine crankshaft. So, this was all about the construction of a reciprocating engine. This, whatever we have studied in this lecture, we are going to see it on a stripped engine. We will be able to see the crankshaft, the connecting rods, the valves, the valve operating mechanism and the accessory section. So, you can see it in the following video. So, in the classroom we have studied about the different parts, different accessories which form an engine. So there is an engine in front of you which is Continental 0470R engine. We have stripped the engine to see the various parts. This is your crankcase, where you can see one shaft here. This is the camshaft. We have studied about the camshaft in the class. You can see the various lobes here. These are the cam lobes. This is your camshaft timing gear, which is meshed with a crankshaft timing gear. So we will see the crankshaft. So you can see here, this is your crankshaft, which is going all through. Here you can see this is your crank pin, which is part of the crankshaft. This is your crank cheek. Two crank cheeks and a crank pin make a throw. We have studied in the class what is a throw. Two crank cheeks and a crank pin, they make a throw. So you can see the shaft here, one throw on this side, one throw here, one throw here. So basically this is a 6-cylinder engine. So 3 throws on this side, 3 throws on the other side. This is your crankshaft timing gear. So this is your crankshaft. Here you can see we have also studied in the class about the dampers to dynamically balance the shaft. So this is your dynamic damper here. So this is your counterweight which is attached to the crankshaft so that your crankshaft is dynamically balanced. On the counterweights you have the holes in which you have the 2 spool pins. These are the spool pins here to provide a pendulum effect so that your crankshaft is dynamically balanced. So this is your counterweight with your dynamic damping. We have seen it in the class. So you've seen the crankshaft, the crank pin, the crank cheeks. 2 crank cheeks and a crank pin make a throw. You've seen the counterweight with your dynamic balancing. So at the end of the crankshaft you have the crankshaft timing gear. This is your timing gear. It is a spur gear. So this crankshaft timing gear meshes with the camshaft timing gear. We have seen it in the front that there is a spur gear, another spur gear, and this crankshaft timing gear meshes with the camshaft timing gear. We have also seen in the class that the size of the camshaft gear is double the size of the crankshaft. So just forward of the crankshaft you have the propeller shaft. Here where the propeller is mounted, this is a propeller shaft. In the class we have seen the different types of propeller shafts, the spline type, the tapered type and the flange type. In this particular engine the shaft is of the flange type. So this is your flange type propeller shaft. So we have seen the crankshaft timing gear. As I just mentioned, this is your camshaft timing gear which is double the size of the crankshaft. This is your camshaft here. This shaft, this is your camshaft, and these are your lobes. Here you see different lobes on the camshaft. So this is your cylinder. We have studied about the cylinder. You can see a lot of cooling fins. This top portion is your cylinder head. This is your cylinder barrel, and this is your skirt area. So this is your cylinder. You can see there is a hole here in the front. This hole, this is for your spark plug. So this is your spark plug hole where your spark plug fits. There are 2 spark plugs on the cylinder. One is on this side, another is on this side. So you can see the 2 spark plugs. These are the spark plug holes. One spark plug, this is your spark plug. This fits in this hole, and another spark plug on this side. So then you have the 2 ports. One is the intake port and one is the exhaust port. And this is your intake port and the exhaust port. So there are two ports, intake port and exhaust port, and you have the 2 valves. This is your valve seating area where the 2 valves are connected. So this is your intake valve and the exhaust valve here. You can see the valve stems, they are coming out. This is how the valve moves, and this is your stem guide here. This is your valve guide here, and this is your valve seat. Now you can see these supports here. They are your rocker arm supports. This is your rocker arm support. We have seen in the class what a rocker arm is. Here you can see this is your rocker arm. This fits in this area, and these are your rocker arm support pins. So you can see the support pins here, and the rocker arm is mounted here, which touches the valve here. If you want to see the inside of the cylinder, you can see the inside of the cylinder here. So this is your cylinder from inside. You can see the cylinder inside. You can see the two valves here. This larger valve, this larger size valve, this is your intake valve, and this is smaller size valve, this is your exhaust valve. So two valves you can see from inside, they are seated on the valve seats. This is intake valve and this is exhaust valve. This area you can see here, this is your spark plug attached. This side you can see this is your spark plug, and this spark plug you can see the electrode inside here. This is the place where your spark is coming out, where the ignition is taking place. The spark coming out of the spark plug ignites the fuel air mixture. This is the place, basically this is the area on top of the piston where your combustion takes place in the cylinder head. So this is one spark plug, this is another opening for the spark plug. We attach another spark plug here. So two spark plugs mounted here, they provide ignition at the proper time and the combustion takes place here. So this is your intake valve, this is your exhaust valve, these are your spark plugs. So here you see this is your piston. So you can see here this is one piston which is connected to the connecting rod. This is your connecting rod here. This piston is attached to the connecting rod. There is a piston pin here. You can see this is one piston where you have the piston pin here. This is your piston pin. This piston pin goes inside the cylinder like this, and one end of the connecting rod, you can see the smaller end of the connecting rod goes inside this piston pin. So this is how the piston is attached. This is your connecting rod, this is your piston, and this piston pin. So the connecting rod attaches to the piston through this piston pin. The other end of the connecting rod, this is the other end of the connecting rod, which is mounted on the crank pin of the crankshaft. So we have seen the crank pin in the crankshaft. This is your place where your crank pin of the crankshaft is held. Within this connecting rod, these are your bearings. You can see there are two bearings which go inside this, and these are the plain bearings inside this big hole which holds the crank pin of the crankshaft. So this is, you have seen the mounting of the piston on the crankshaft. Now coming to piston, you can see there is a piston in front of me. This is your piston head. We call it a crown area. This side portion, this is called the piston skirt area. You can see on top of the piston there are two recesses. We have seen in the class that the piston head had got two recesses. These are the valve recesses. These are two depressions here on the top of the valve. So on this piston you can see various rings. We have studied in the class. There are rings, different types of rings. On top you can see these are the compression rings. Then you have the oil control rings. You have the grooves here on the piston. Between the grooves, the area between the grooves is called the land. This is called the land area. Top rings are called the compression rings. This ring just above the piston pin hole is your oil control ring, and the ring which is just below the piston pin hole is your oil scrapper ring. So you can see the piston here. I have the rings here in front of me, different rings. You can see these are your compression rings. This is your oil control ring. This is your oil control ring, and this is your scrapper ring. This is your piston pin hole where your piston pin fits in. This is how the piston pin goes inside. You can see this piston pin goes inside. This is inside of the piston, just on the bottom of the piston, and here your one end of the connecting rod fits in. This is how the connecting rod fits in. The piston pin, this goes through the smaller hole of the connecting rod, and this end of the connecting rod fits on the crank pin of the crankshaft. So this is how the piston and the crankshaft are connected to each other. Now coming to valve mechanism, we have studied in class about the valve operating mechanism. Let me show you the different parts which are there in the valve mechanism. You can see the two valves. We have studied the different types of valves, the tulip type valves. You can see the two sides of the valves. The bigger valve The bigger size is the intake valve, the smaller size is your exhaust valve. Now this is your valve stem area, this is your valve stem area, this is your valve neck, and this is your face area. This is your valve tip, this is the tip. Since this is a bigger size, this is intake valve and this is exhaust valve. We have seen that the exhaust valve, since it is exposed to very high temperatures, it is exposed to corrosive environment. So this face of the valve is coated with a hardened material called stellite. So and also on the tip. So because on the tip you have the continuous hammering of the rocker arm. So and at the same time the valve is grounded to a certain angle. You can see the two valves, the exhaust valve and the intake valve, they are grounded to a certain angle we have seen in the class. So these are the valves. We have seen how the valves are connected in the cylinder, how the valves are seated inside the cylinder, we have just seen it. Then we have also seen the valve springs. These are your valve springs. We have read that two springs, one inside the other, are mounted. So these are the two springs. You can see the two springs which are over the valve stem. They go like this. Just on top of the valve springs you have this washer. It goes like this. And in order to keep the complete mechanism locked, you have the valve stem keys. These are called the locks, the keys which hold the complete unit like this. It keeps it locked. Since it is spring loaded, it is under tremendous pressure and keep the complete mechanism locked. Now this mechanism, this is your valve rocker arm. We have seen in the class, this is your valve rocker arm. This is this end, this is your tip end, and this is, you can see here, a small hole. This goes like this. This end touches your stem like this and is hinged to the rocker arm support pin. Here in the cylinder you see it goes like this. This is your rocker arm support pin. These are your rocker arm supports. It is mounted like this. This pin goes inside this and it is like this. This end, you can see this end, this hammers the tip of the valve continuously to open the valve against the spring pressure. So the springs keep the valve closed. In order to open the valve, a pressure has to be exerted against the spring pressure to open it. The other end of the rocker arm, this end is connected to the push rod. This is your push rod. We have seen in the class, it is a hollow tube with two ball ends. You can see one ball end here, another ball end here, plus it has holes so that the oil is transferred for lubrication purpose. So this one end of the push rod is connected to the rocker arm like this. Now this push rod is inside the guide. So you have the guide here. It is like this. This guide is mounted on the crankcase engine and it goes like this. So this is your push rod. We have seen in the class what a push rod is. It is a hollow tube with two ball ends, one on this side and another on this side. It has holes for lubrication, for transferring of oil. So this push rod is going through this guide. You can see a guide here. This is your guide. This push rod goes through the guide. So here we have arranged it so that you have a clear picture. This is your push rod which is going through a guide. This is your valve lifter. We have studied in the class what a valve lifter is. This is your valve lifter which is connected to one end of the cam lobe. So here you can see in the engine, this is your cam lobe. This cam lobe pushes this valve lifter here. You can see this is this valve lifter. This is pushed by the cam lobe. The force of the cam lobe to the valve lifter is transmitted to the push rod. So this basically the circulatory motion, the rotary motion of the cam lobe is converted to linear motion, the reciprocating motion of the push rod. So the cam lobe is pushing the push rod this push rod is being pushed here. Now here you see this is your rocker arm which is being pushed by the push rod. So when it is pushed by the push rod here, this rocker arm goes down. The other end of the rocker arm is connected to the wall like this. This is your tip of the valve and this is your valve, and when this pushes it from here, this rocker arm goes down and this valve goes down against the spring pressure. So I'll show you here on the engine. We will try to turn the engine and show you. This is your cam lobe, this is your valve lifter. The push rods are going through these guides. This rotary motion of the cam lobe is being converted to reciprocating motion of the push rod via this lifter. Once this push rod is pushed, this push rod will push the rocker arm here. This is the rocker arm. This push rod will push the rocker arm here, and now once this end of the rocker arm goes up, the other end goes down. Since it is hinged in the center, this end will go down. So like this, when this goes down, the valve goes down. We'll try to turn the propeller, we'll try to turn the engine and see how it looks like. So see, the engine is being turned. Now you can see the camshaft moving here. The camshaft moving, you can see the various cam lobes moving. Now the top end of the cam lobe pushes the valve lifter. You can see the valve lifter here, it is moving. Once the valve lifter is moving, you can see the push rod being moved. Once the push rod moves, you can see the rocker arm moving, and the rocker arm, when it goes down, you can see the spring also going down. So this is your complete valve operating mechanism. The camshaft, cam lobes, the valve lifters, the push rods, the rocker arm, the valve, along with the springs. So this is your valve operating mechanism. So we are trying to turn the engine. The engine is being turned. You can see the camshaft rotating. Here you can see the camshaft rotating, the cam lobes moving. These are your valve lifters. You can see the cam lobes, they depress the valve lifter. Basically, the rotary motion of the camshaft is converted to reciprocating motion of the lifter and the push rod. So you can see the cam lobe depressing the valve lifter here. This is your valve lifter. So when the camshaft is moving, the cam lobe through the lifter, it pushes the push rod. The push rod, this push rod is going through this guide. This push rod, this is pushed here. You can see here, when this push rod is pushed, the rocker arm, you see this rocker arm, see here, this is being depressed. This rocker arm, see, this rocker arm is moving. It goes up and then it pushes the valve here. You can see the valve here. See this rocker arm, it is being pushed here by the other end. So this was all about the different parts, the construction of the engine, the reciprocating engine. Thank you.